platform practitioner looking to tighten up your mental models, or you just want to see how a data science project actually goes from raw numbers to tangible business value, you are in the exact right place.
Okay, let's dive right into this. Here's our roadmap for today. We'll hit core ML concepts, preparing the data, choosing the right model, avoiding common pitfalls, measuring model success, and finally, we'll wrap up with the ultimate golden rule. Let's get to it.
Section 1. Core Machine Learning Concepts. Foundations first.
Before we even think about touching a dataset or writing any code, we've got to set up the rules of the game. At a high level, machine learning pretty much splits into two main camps. First, there's supervised learning. Think of this like having an answer key. We are literally feeding the model input-output pairs so it learns to predict specific outcomes. This is your classic regression for predicting house prices or classification for catching fraud. On the flip side, we have unsupervised learning. Here, there's absolutely no answer key. The data is completely unlabeled. The algorithm's only job is to dig in and discover hidden structures, like naturally clustering different customer segments together.
Now, what's really interesting here is the actual statistical engine running under the hood. We've got generative models versus discriminative models. Generative models learn the joint probability distribution, meaning they figure out exactly how the data was created from scratch. And because they know the recipe, they can actually generate brand new data points that look just like the original set. Naive Bayes is a classic example of this. But discriminative models, they honestly don't care how the data was made. They simply learn the conditional probability to figure out the boundary between classes. They just draw a literal line in the sand, which is exactly what support vector machines or logistic regression do.
Moving on to Section 2, Preparing the Data, or as I like to call it, Cleaning the Mess.
You know, in textbooks, data is perfect. But out in the real world, it's a massive, messy headache. The very first thing you'll hit is missing data. Our source gives us a really solid playbook here. Step 1. Absolutely always check your missing percentage first. If you've got holes in categorical data, say a missing insurance type, you use mode imputation. You're basically just filling that gap with the most common category. For numbers, you want median imputation. It's way safer than the average because it doesn't get completely derailed by extreme outliers. And please notice that last point. You strictly avoid deleting rows. Unless a column is missing more than 40% of its data, deletion is your absolute last resort.
Okay, next up is imbalanced datasets, which is a huge deal. Imagine you're building a fraud detection project, but only about 8% of your transactions are actually fraudulent. If your model just lazily guesses not fraud every single time, boom, it's over 91% accurate, which means accuracy is a completely useless metric here. To fix this imbalance, you can apply class weights, which basically forces the algorithm to pay way more attention to the rare cases. Or you can use smoke to artificially spin up synthetic minority